We'll wind up Unit 2 with pages 49 and then later 50. So what we're asked to do now is to find the rule or equation of a parabola given the vertex and it passes through a given point. So what we'll need is the vertex formula, and then basically we're going to solve for A. So let's get started here. Well, we know y here is going to be a -3. We don't know what A is. Now we know that x is going to be 0 here. And then now we know our vertex will be a -1, opposite sign. And our k will be a -4. So and I didn't need the two negatives there. So when we look at the vertex in this form 1, in this form here it's a -1. So that part's good. So now we actually do our calculation, and this is squared. So this is going to be -3 equals A. Now we have here a -1 that we're going to square. That makes it a +1. So we can put that one right there or not write it at all. And then we have a -4 from out here. We want to solve for A. So we bring our -4 over to this side as a +4. +4 and -3 give me a +1, and that equals A. So our A here is just going to be a +1. So now we write it as the rule, which will be y equals, now we could write the 1 there, we don't need to, x minus 1, the quantity squared, minus 4. So there is the rule for example 1. Now let's do the same thing for example 2. We're going to substitute in here the y and the x here from this point, and then the vertex for the h and the k. So our y here is -6 equals A times x, which is a -1, this x. Now this is going to be a +3 here, the quantity squared, and then a -10. We want to solve for A. So this is a -6 equals, we do our subtraction here, we get a 2. 2 squared is 4, so 4A minus 10. Now we transpose our -10 to this side, becomes a +10, and this then becomes a 4 on that side. Divide both sides by 4, so we get our A equals 1 again. So putting it in the rule now, it will be 1, or y equals a 1 that we don't need to write. That would be our A value. And then x minus, this will be then a +3, opposite sign here, and then -10. And before we leave this page, we want to note that if our A is positive, then of course our parabola is going to open upwards. And we then know which kind of parabola we're going to have depending on our A. That's why we needed to solve for the A. Now, as we mentioned, you can always pause the tape here and look at something before we start, and you give it a try. But if you're having difficulty, and you can go back and you can actually advance it ahead if you catch on what's going on. So what we have here now, we have 1 point, so we're going to use that 3 for the y out here, equals A. Now the x will be a 1, and it'll be opposite sign of this, so negative 3, the quantity squared, and then plus 7. We're looking for the rule. So we're going to do this. We get a negative 2 here that we're going to square. So that'll give us 4a here. This is a 3, and this is plus 7. Now we're going to subtract 7 from both sides. And here this will be a negative 4 equals 4a. Now when we solve for a, we get a equals a negative 1. So now our rule as we write it, y equals a negative 1. That's our a value. Now we don't need to write the 1 there. We could have just left it, but our book is showing it this way. And then x, opposite sign, minus 3, the quantity squared, and then plus 7. All right, going on to example 4. Now here, this will be our x and y. So we have 5 equals a times x, which is 0. Now opposite sign, so this will be a plus 1, the quantity squared, and our k value is 3. So we do this, we ended up with a positive 1. Squared is 1, so this is just going to be a. We're going to subtract 3 from this side, 3 from this side, and we get a 2. So now our a is 2. So in our formula, y equals 2 now, x opposite sign plus 1, the quantity squared, times our plus k here, which is 3. And there's our rule. Now before we leave this page, let us note here that this parabola is going to open downward, and this will be our maximum here, and we already know the vertex. The axis of symmetry is x equals 3. Whatever the 3 value is, or the x value there, that's our axis of symmetry. So as we look at our point, our y value here is 0, so 0 equals a times, this is our x here, 2, opposite sign, plus 1, the quantity squared, plus k. So we get 0 equals, now 2 plus 1 is 3, 3 squared is 9, so this gives us 9a, and our k value is 9. In fact, we could have written it there instead of putting a k. So now we transpose the 9, we get a negative 9 on this side equals 9a. Solve for a, we get a equals negative 1. So our rule now is y equals a, which is a -1, times x, opposite sign, plus 1, quantity squared, plus 9. So again, if you're familiar with this formula now, and we've worked on it for a while, these work out rather easily. This is our last page in our second unit, and we're going to work on some more parabolas and use some of the information we've gained. So here a researcher has cited a good model is this, where y is the number of responses per millisecond and x is the number of milliseconds since the nerve was stimulated. So this is in standard form, sort of. We see it's going to go downward because our a value is negative, but we can factor out a negative here, -1. And then we change all the signs. So this is x squared plus 40x minus 80. And then we can do what we've done because we want to find our maximum, which is our y value out there. So let's just set this up. X squared plus 40x minus 80 out there. Well, actually, we changed that sign, didn't we? So when we put it in the Vertex formula, we take half of 40, get a -20, square it, and that brings us up to 400. We have to subtract 400. And then -400 plus 80 gives us 330, and it's the opposite sign from out here. So this is going to become a positive 320. And we have then our vertex here is going to be, when will the maximum firing time be reached? And it would be this point, which is opposite sign 20. And what will be the maximum firing range? And that is 320. And those answers check. Now in example 2, they're saying a bullet is fired upward from the ground, and it goes up, runs out of speed, and then it drops back down. Now they're defining that by this formula. Find the maximum height and the time in which the bullet will hit the ground. That's over here when it's 0. So the maximum height, now I'm a little surprised how this is set up because of the a value being negative, but you can divide everything by a -16, and then this will become positive. And we can factor out then a 16. So 16 t squared minus 1024 t plus 0. So we're going to factor out a 16 here. 16. This then gives us t squared minus 64t. We're going to put the plus 0 out there. We're going to then take half of 64 here and get 32. We're now going to square 32. Or we could have just factored out a -16 here. This was negative and this one was positive. Factoring out a negative 16, we get this. All right, and going through the procedure, taking half of this. Now, squaring this, we get this that we have to now subtract. But keep in mind, we took out a negative 16 here. So negative times negative gives me this. So the maximum height reached by the bullet then, this is the maximum, and that is 16382. Now, when the bullet's going to hit the ground, remember our ground is 0, so we have this formula, a negative 16 t squared plus 1024 t equals the ground, which is 0. So something again we've done is to factor this. Let's take out a negative 16t. This will give us t, and we divide this by that. That gives us a negative 64 equals 0. And we use the zero factor properties. So negative 16t equals 0, or t minus 64 equals 0. So this is just going to be 0. That's when it's fired. But here, t comes out to be a positive 64. So firing this bullet 64 seconds after it's fired, it's going to hit the ground. And that wraps up our lesson. So for Unit 2, you can expect a test, and hopefully these have been helpful for you.